Hi guys, this is Mr. Gravakis. I'm here to chat with you about exponents, specifically rational exponents. So what does it mean to be a rational exponent? A rational exponent is just a fraction as an exponent. So instead of an exponent of 2 or 3 or 4 or -1, we're now dealing with fractions. So what does this mean? By definition, if the nth root of a is a real number, m is an integer, and m over n is in lowest terms, then a to the power of m over n can be written as the nth root of a to the m, or the nth root of a all to the m power. So what happens here is this guy right in here, this little n, is called the index. So the index is going to change, and the index is always going to be in reference to what the denominator of the fractional exponent is. Now, the one thing to note here is that you have been working with a root already. So when we work with an index of 2, that's known as a square root. So what happens is we can look at this as just square root of a. If there's no index in here, we automatically assume it is a 2. So what happens is this ends up looking like this under a root, but then ends up looking like this as a fractional exponent. So what we want to talk about next is the process of simplifying these problems in the context of having fractional exponents. So we need to make sure that we have one of each base at the end of it all. Now, this does not apply if you are rationalizing, and I will do an example that requires us to rationalize. So we want to have one of each base unless rationalizing happens. We want to have no negative or zero exponents, and no fractional exponents are in the denominator. So if you remember from the last slide, fractional exponents are radicals, they're roots, and roots in denominators are not good in math. So we've fixed this before. We have rationalized before. Same rules apply with fractional exponents in the denominator. We have to fix it. And I'll show you how in one of our examples. Okay, so first thing we're going to do is just convert between rational exponents and radical form. So p to the 3/8 can be written one of two ways if we switch to radical form. We can write it as the 8th root of p to the 3rd, or this also can be written as the 8th root of p all to the 3rd power. Either one of these is an acceptable answer. Number 2 has us in radical form. Now we need to convert to exponential. So there's a couple of different answers for this one as well. So you can do one of two things. Either you can write this as 10k to the 3/4 power. The other way that you could write this is 10 to the 3/4 and k to the 3/4. What's not okay, though, is if you wrote 10k to the 3/4. This is not okay. You need parentheses when you were working with something like number 2. Now let's get into the more nitty-gritty. So let's simplify using laws of exponents. So I like to distribute first separately the two parentheses. So I would use my power of a product property. I'll get the squared, and then everything in that second set of parentheses all gets that 4th exponent. Simplifying all of that, take a second. So after that, I get 9x squared, y squared, 1, x squared, and y to the 8th. So then the last thing that I want to do is check for my like terms so that I can add my exponents. So I have an x squared, I have a y to the 2nd, and a y to the 8th. And then I have a 9 and a 1. So my final answer for this one will be 9x to the 4th, y to the 10th. Let's move on to the next one. All right, so what I like to do for this one is I like to simplify numerator and denominator separately and then take a look at the fraction as a whole. So what I'm going to do is I see I have 2 x's on the top, 2 y's on the bottom. I'm going to simplify those first. This right here, x to the first, I'm going to rewrite as 2 over 2 so that I can easily add these exponents. So I have the 2, and then I have x to the 5/2. So then on the bottom, when I'm talking about the y, specifically this -3, I want to make it so the denominator is the same so that I can add them. So that means that -3 is the same as -6/2. So -6/2 plus 1/2, that gets me y to the 5/2, -5/2. Okay, now I'm going to look at this as a whole. I don't have to subtract anything because I don't have any x's in both the top and the bottom. I don't have any y's in the top or the bottom, but I do have a y that has a negative exponent. So that means that I'm going to switch where that is. So that y value will come to the numerator. And then only 1 is left in the denominator. So I don't need to write that. So this would be my final answer for this one. One quick note before we move on to the next question. If your exponents start as fractions, if your problem starts with fractional exponents, your final answer should also have fractional exponents. Do not worry about converting your fractional exponents to radical form. This is just a waste of time for you. So if you start with exponents as fractions, do not convert to radical form for your final answer. Keep your fractional exponents. Okay, so for this one, we have a parenthesis around the whole thing to the -2 power. So I like to take a second and I can't simplify that inside of the fraction at all. So I'm going to, what I say, distribute the -2 exponent. So then the next thing I notice here is that all of these are negative. So all of these exponents are negative, which means that all of these will be in the opposite place. So 3 to the -2 will come down to the denominator. B to the -2 will come down to the denominator. And then 5 to the -2 will come up to the numerator. So we'll be working with, so then taking a second to simplify this. This one's not too bad. We just get 25 over 9b squared. There's nothing else we can do with that one. So that is the final answer for that one. All right, our last one. So we haven't done one yet that has had rationalizing. So this one does have rationalizing so that you guys can see how to approach it. So the one thing to note here is that you want to make rationalizing the very last thing that you do. So you are going to go through the problem and apply all of your rules of exponents first, and then once those are all set, then check if you need to rationalize. So right away I see n to the 0 power here. I automatically know that this is 1, so that one I can ignore, if you will, because it's just a 1. So then the only thing I have up here on top in the numerator is that m to the 7/4. So I can't do much else with that. I do have to do a little bit of work in the denominator though. I have this set of parentheses, so I distribute the 2. I'm going to take a second to simplify that. All right, I still have 2 m's in the denominator, so I'm going to, again, take one more move and combine those. So now I have m to the -3 and n to the 3/2 in the denominator. So I know that anything that's negative needs to go in the opposite place. So I know that m to the -3 down in the denominator is going to move up to the numerator. So now I have, all right, I'm going to combine my terms up top, and then I'm going to see if I need to rationalize. I have no other n's to consider, so my m's are the only thing that I need to finish. I need to add 7/4 and 3, so I'm going to change this to 12/4. 7 and 12 get me 19. So the note up top is going to be m to the 19/4 over n to the 3/2. Okay, now is where you would consider, do I or do I not rationalize? If we have a fractional exponent in the denominator, the answer to that is yes. So how do we fix it? The way to fix it is think about this fraction and think about what you have to add to it to get to the next whole number. So right now this is 3 halves. If I add 1 half to that, that's going to get me 4 halves, which is 2. So in order to do that, in order to add 1 half to 3 halves, we need to multiply by n to the 1 half. But in math, in order for us to stay balanced, what we do to the bottom, we have to do to the top. So then the final answer for this one is m to the 19/4 times n to the 1 half all over n squared. Now, I know that we have an n both in the numerator and the denominator, but as we said before, if we have to rationalize, that is okay. You guys might find that you end up going in circles with this if you still continue to apply the rule. So if you take a second and say, well, I have an n in the top and the bottom, I need to now subtract my exponents, you're going to end up back before we did the rationalizing and just end up in this circle. So be very careful. Apply all your rules first, then determine if you need to rationalize. If the answer is yes, then it's okay if you have a variable in the numerator as well as the denominator.